Sardar Vallabhbhai Patel Education Society managed R.N.G Patel Institute of Technology, previously known as FETR, is one of Gujarat's leading institute based in Bardoli. The institute is recognized by AICTE and affiliated to Gujarat Technological University. The institute was established in the year 2010. The institute has 5 engineering streams: chemical engineering, civil engineering, computer science and engineering, electrical engineering, and mechanical engineering. The institute has 7 departments, including science and humanities and workshop. The institute has dynamic curriculum, robust and talented pool of faculty members, and state-of-the-art infrastructure in all the departments. It is well known for imparting quality education, active research, and also nurturing students for holistic development achieved through student engagement tools like continuous evaluation, practical-oriented learning, departmental electives, soft skills development, and many more. Recently, RNGPIT has started AICTE-approved and Gujarat Technological University affiliated 3 years industry-oriented graduation program, Bachelor of Vocation on Skill Development Based Higher Education. The institute has 3 BVOC courses: BVOC in Software Development, BVOC in Production Technology, and BVOC in Refrigeration and Air Conditioning. The institute has organized 144 expert talks, 165 industrial visits, 90 workshops, 76 seminars, 32 STTPs, and 20 faculty development programs till today. The institute is proud of its academic results. RNGPIT is continuously securing top rank at state level and zone level in Gujarat Technological University. India's first Common Engineering Facility Center, governed by Setu Foundation, is being developed at our college campus. The institute has signed MOU with UGEC PowerMax Private Limited Vadodara for skill development, industrial training in wind energy, with Aspiring Minds Gurgaon for the job placement, for Trivedi Global Education Mumbai for the guidance of higher education in abroad, with E.Yantra IIT Mumbai for the development of robotic laboratory, and with Reliance Jio for the development of recruitment and training center in the field of ICT. Training and placement cell of the institute is active and alive. RNGPIT has organized 2 job fairs in the association with Directorate of Employment and Training, Government of Gujarat, and N.G. Patel Polytechnic. The institute has organized 2 IT job fair in the association with Surat IT Company Owners Association, SICO Surat. The institute has started SSIP cell for development of innovative projects and patent generation. Various projects done by our students have been presented at National International Expo and Enclaves. RNGPIT has established NPTEL local chapter for various online courses provided by IITs. Institute has run various skill development courses free of cost under Pradhan Mantri Kaushal Vikas Yojana approved by National Skill Development Corporation. RNGPIT has developed Hansaben B. Poonawalla Vocational Training and Research Center with 14 advanced well-equipped laboratories. The institute has developed Tinkering Lab with the Association of Student Startup and Innovation Policy Cell, Gujarat State, in which students can enhance their knowledge in the field of IoT, robotics, artificial intelligence, 3D printing, calligraphy, and many more. The Chemical Engineering Department of RNGPIT is recognized as Schedule 1 Environmental Auditor by Gujarat Pollution Control Board, Gandhinagar since 2012. The institute has around 40 industries allotted by GPCB for their audit work. NABL accredited Environmental Audit Consultancy Laboratory and Civil Material Testing Laboratory of the Institute have acquired ISO 9001-2015 certification. There are many achievements done by faculties and awarded by gold medals. Every year, students have been facilitated with gold medals.
Hi, I'm Zainab Anjani and I'm a software engineer in Silicon Valley. I did my master's in computer science from California State University, Sacramento, and I did my bachelor's of engineering in computer science from FETR, which now known as RNGPIT. I have been asked to share my thoughts on a few key areas. So the first one was the campus life. So I can definitely say it was both fun and studies. Studies in the sense that we had to prepare for Viva, GTU exams, and for writing assignment. And another thing is the fun part was that we used to have two kind of activities. Like one is the Vishwa Smoothie, which I personally liked the most because it was of both, combination of both gaming activities and coding. And another one is the Kashish. So in that dancing, singing, so and other cultural activities too. So it was very much enjoyable.
The institute has been awarded with the Appreciation Award for Green Campus at Energy Expo by South Gujarat Productivity Council. In our campus, more than 3,000 trees plantation and 194 number of solar panels with 65 kilowatt capacity for utilization of energy. Students are given full facilities of library with a collection of around 15,000 volumes, 4,000 titles, 30 national and international journals, and 30 magazines. The institute provides facility of book bank and digital library to the students. The canteen facility is situated within the college campus. All type of hygienic meals and snacks are available at subsidized rate. Our institute provides hostel facilities for our college students. Vishwa Smriti, Cultural Festival Kashish, Sports Week, outbound training, and festival celebrations are carried out for students' welfare and growth. R.N.G Patel Institute of Technology strongly believes in all-round development of the students who can shape the better future.
Good afternoon, one and all. Myself, Professor Sachin R. Patel, Technical Coordinator for this webinar on DC Power Supply and its application. This webinar is organized by Electrical Engineering Department of R.N.G Patel Institute of Technology College, Bardoli. As we have our eminent speaker with us, so I would like to request today's session moderator, Professor Nirav Salunke sir, working as Assistant Professor in Electrical Department at RNGPIT College, to please welcome and introduce the profile of our eminent speaker. Over to you, Nirav sir.
Thank you, Sachin sir. So, good afternoon to all of you. I am Professor Nirav Salunke, Assistant Professor in R.N.G Patel Institute of Technology, that is RNGPIT Bardoli. Welcomes you all on this wonderful session. Today, we are going to arrange a webinar on DC power supply and its application. As far as RNGPIT is concerned, during lockdown period, we have arranged series of webinar for the upgradation of students as well as faculty members. For that, today we are having one of the expert with us, Mr. Saunak Bhalsod sir. Sir has completed his bachelor degree in electrical engineering from LDRP ITR, Gandhinagar from GTU. Sir has completed his MTech from Power Electronics Machines and Drives from Nirma University, Ahmedabad. Sir is currently working as a power delivery engineer at Intel Bangalore. Before, Sir has worked with design engineer in power electronics in Centum Electronics Limited, Bangalore, for the space and defense application for more than 1.5 years. Sir is having 1 year of experience as a MTech project trainee on space power electronics project on electronics power conditioner at Space Application Center, ISRO, Ahmedabad. Sir has worked on various advanced trends, techniques and devices in power electronics, including gallium nitride devices, DC to DC conversion topology, advanced PFM and PID digital controller algorithm, and planar magnetic packaging technology. worked with different, sir has also worked with different microcontrollers such as STM32, DPIC 33, TIC 2000 and several FPGA, that is field programmable gate array. So today sir will give us the knowledge related to DC power supply and its application. Now over to you sir, hand over our podium to you and now you can carry on your session sir. Saunak sir.
Thank you so much, Professor Nirav, for giving me this wonderful opportunity, and thanks for giving me this awesome introduction. Okay, so yeah, so friends, here we are having the topic of DC power supply and its application. So we'll not wait, and we'll go to our session. So yeah, I think all of you know me. So already Nirav has introduced me. So yeah, I am power electronics engineer with 2 years of experience, mainly on space, defense, and computing segment. At present, I'm working as a power delivery engineer in Intel. Yes, you're right, that computer processor company. I'm tech in power electronics, machines and drives from Nirma University. Yeah, that washing powder Nirma. Uh, MTech dissertation in Space Application Center ISRO on novel DC conversion for communication satellites, and B in electrical engineering from GTU. Yes, that famous GTU which all of you are studying. Yeah, so I can say that I'm one of you. So hope to see you in this position in future. Yeah, so today's agenda is we'll first of all go through the introduction on DC power supply. Then we will move on to its fundamentals. What are the types of power supply? Its major components. What is the principle of operation? And few application examples. Okay. So, and if time permits, we'll move to real-time examples or some of the simulation of the power electronics and DC converters. So now we are at Industry Revolution 4.0, in which without almost all gadgets are we are at wireless gadgets. We are using multiple technologies and multiple instruments, multiple devices, which will always use some of the way of power supply. So each and every device needs its own power supply. So in this industrial revolution, it is mandatory to have good understanding in power supply topology as an electrical engineer. So yes. So what is a DC power supply? DC power supply is nothing. It's like all other power supply, which controls and regulates the DC voltage and distributes throughout the systems. Okay, just like our body. So our body has blood vessels, and blood will flow through the body, and same as power will flow through its power supplies and its circuitry. So what are the power supplies available in real life? So let's say we have several inputs such as battery input for almost all kinds of portable applications such as laptops, your smart gadget, or your smartwatch, or your smartphones. Second type is your AC input, which is available in your house probably, which is 230 volt AC, which is standard in our India. And fourth one is ultra low voltage input, which will come in application of energy harvesting, let's say piezoelectric or solar applications or any other renewable source. Okay. So all 4 types of inputs are available in real time, in real world. So this will be act as input, okay, for the DC power supply. So we'll move on to the application. So before understanding the DC power supply, it is mandatory to understand where it will be used. So which will give you more interest. So it is almost everywhere. As I mentioned, Industry Revolution 4.0 will require DC power supply in almost all kind of applications. So it includes personal electronics, which is known as commercial application. Second one is automotive. Automotive means your transportation, your electric vehicles, your normal vehicle, your two-wheeler probably, which will use some of the way of the DC power supply, which might be using your battery. So all of you might be knowing which in electric vehicle or in any usual vehicle will have one battery, and which will supply to its internal components to function your vehicle properly. Third one is transportation, like maybe let's say you can tell your trains, your metro, everywhere it will be used. Fourth one is healthcare. So in healthcare equipments, all equipments needs proper calibrated DC power supply to function accurately, because healthcare is the most reliability hungry. So it needs reliability. Otherwise, the human health or any person's health is in danger. Fourth one is aerospace. So yes, in aerospace, practically needs its power supply to function all its control circuitry and its secondary circuitry, its altitude control, its almost everything which needs the power. So for that, we have dedicated power supply for the aerospace. Fourth one is defense. Yeah, defense, all kinds of warfare systems which needs proper power supply. Maybe it must cater for customized power requirement, because it is not be available to normal people. So it might be some dedicated power supply for the defense application, like let's say in missiles. So in missiles, some of the control algorithms, some of the controller circuit, which will require the power supply. So you have one battery, and from battery you have to distribute some voltage rails to the power supply, to the control circuitry of missiles. Fourth one is space. Yeah, in communication satellite, in military satellite, in all kind of satellites requires power system. So that power system will consist multiple DC power supplies, because in space you all know solar panel is the source for the power for that particular satellite. And last one, electrical power grid applications. So almost all kind of power grid needs DC conversion, which will be used for any kind of control circuit, or even you can consider high voltage DC application also will use the DC power supply. Okay, so we'll move to next slide. Yeah, so we'll go to personal electronics. Yeah, I already explained. You can see in the picture, whatever equipments are shown requires DC power supply. So you can see from computer to laptop, TVs, your phone, your smartphone, your smart gadgets probably. So you might be using your smartwatch. So it has one battery, and from battery you have to give proper voltage to the functioning circuits. Even your PlayStation probably, you might be using some gaming consoles, Xbox, all needs DC power supply. automotive, nowadays it's a trend in this industrial revolution 4.0, which is electric vehicle and hybrid electric vehicle. It's battery management systems, onboard battery charger, wireless charging, DC motor drive and powertrain. Typically, it's nothing but your DC to DC conversion. Transportation. So this is also one of the key application for the DC power supply, which will be used in electric traction, trains, railway power, electrification, and its control unit. Healthcare, yes, medical power supply, as I told, it requires highest reliability, wearables, electronic medical equipment, ventilators, ECG, and the testing and monitoring systems such as X-ray machines, MRI machines, which needs dedicated, customized DC power supply, which must be very precise to function as desirable, because it's human health, which comes with a great value. It's very precious. So it's I think we can consider most precious in Earth, so that we have to be very careful for the equipments which are used for the healthcare. So which will follow some specialized standard for its DC power supply. Same as aerospace. Yeah, you can see nowadays many people are using drones. Even nowadays, police also using drones to detect any people who is outside in lockdown period. So you might have seen those kind of drones, which will use typically main source as a battery, and it will have its own DC to DC converter, and which will supply its motors, all four motors in controlled manner. It will have its own electronic speed controller, which is nothing but one kind of DC to DC converters. Apart from it, aerospace applications consist of aircraft main electric energy system, which is nothing but your some big batteries, and which will supply to its aircraft cockpit display, aircraft engine control, flight control system, its auxiliary circuits, all the necessary utilities, so that its entire lights, illumination, everything will be given from DC to DC converters or DC power supply. In defense, so as I mentioned, defense, it has many applications in electronic warfare, radar, sonar, which needs its own dedicated power supplies to function it properly. We cannot use normal power supply. It will have certain guidelines, certain standards, certain military standards, which it has to follow, because it will generate some noise, and also we have to be careful while designing. But it has its application in fighter planes, military communications, surveillance systems. So in space, yeah, we can see that in right side we can see the International Space Center, which has so many solar panels, and ultimately it will give the power to entire Internet Space Center to function properly, which will consist very high efficient DC-DC converters. Apart from it, you can see some propulsion systems for satellite, which will use electric propulsion, not the ion propulsion. So which will need the electric power conversion. Ultimately, it's a DC to DC conversion. So yes, there also it will be used your DC power supply. Third one is, last one is your electric power grid applications. So grid power system, smart grid, renewable energy. You all know renewable energy is nothing but your DC to DC conversion only. So in case of solar energy, your solar lights or radiation is converted into electrical energy, which will always be in a DC voltage. So you will get from solar panel only DC voltage, and that you will boost it, and again you will convert it into your AC voltage. So that also will have one stage of DC to DC conversion, or even multiple stage also possible. So yeah, so this is the applications where it will be used. Next, we'll move one uh, dedicated application for the electrical power system for satellite, which will use DC to DC converter. So yeah, as you can see here, we have solar array, from which we will get the main DC power supply, which will be unregulated. So which will not have fixed voltage. It will be very depending upon your solar intensity or your sunlight or its position, how it is. So in order to adjust this solar panel, we will have motor control for in which again needs its DC power supply. So that again it will come from solar energy, and it will have battery. You can see the power conditioning unit will have all kind of battery and its charging, discharging, functioning circuits, and which will give again one more stage of power distribution, and which will give the completely regulated power supply. And after that it will again distribute to its main payload, which is our traveling wave tube amplifier or solid state power amplifier, which will be used to amplify the signals and whatever application the particular satellite has been designed. So that will be given to your payload. So the EPC high voltage stands for electrical power conditioner high voltage, which is nothing but the DC to DC converters, or it is a terminology used by space scientists instead of DC to DC converter. So that will be high voltage DC to DC converter, which will be used for TWTAs, which is nothing but your traveling wave tube amplifiers, which will be used to enhance the signals which is coming from Earth, and again from Earth it will go to the satellite, it will be amplified, and again it will be processed, and again it will go to some other place of Earth. So that is the function of TWTAs. SSPAs will have some low voltage, which will, but the functionality remains the same, which will give low power, but it will have its own application. Apart from it, the communication satellite has its own circuitry, which again needs your DC to DC conversion. So for that, again, it needs dedicated DC to DC power supplies. Apart from it, satellite needs its own attitude control, its communication, some telemetry, command and data handling, and professional thrusters. All needs DC to DC conversion. So it has again dedicated DC to DC converter. And apart from it, your motor controller needs one more DC to DC converter to adjust its solar arrays. So this is the complete block diagram of the satellite. So you can see it as an electrical power system. DC to DC converter is the heart of the electrical power system for satellite. We'll move to the next. This one looks pretty interesting, as it's electrical power system for electric vehicle, which is soon going to be the universal for the world. You will see on the road everywhere electric vehicle compared to the conventional mechanical or convention vehicles which used your petrol or diesel engines will be replaced by electric vehicles once this battery technology and conversion efficiency will be good enough to be practical for the transportation applications. So you can see it has its own, we'll start from the normal charging connector. So that which will be outside of your electric vehicle. You can see, you might have seen some big chargers outside the electric vehicles, which will connect to the electric vehicle. Again, electric vehicle will have its own board battery charger, which is nothing but one DC to DC converter. Again, it will be from there, it will be given to the inverter as a power source, and it will again given to the battery to charge the batteries. So you can see the battery is connected to the onboard charger. So it will charge the battery, and it will be again given to the inverter, to the motor which will drive your motor. So which is the main horse of the electric vehicle. So yeah, in that also you can see the DC to DC converter plays very vital role for the electric vehicle. Now, after understanding its application, it will be very easy to uh, go to the little bit insight of the DC to DC converters. So we'll first start with the very basics: unregulated power supply. As name suggests, the unregulated power supply, the output of the power supply will not be regulated. It will solely depends upon what is the input or what is the load. So the load, if your input is less, definitely your output will be less proportionally. If your load is high, again your output will be less, because you don't have any eyes on the output, no control system available on output. So it will be used in the application where your output voltage does not require precise value. So which will have some range. Let's say if your output voltage is 5 to 8 volt from your mains input. So if your mains input fluctuates between 230 volts or 200 volts to 230 volts, your output will fluctuate 5 volt to 10 volt. So in that case, if your application or if your load is fine with that, you can use this unregulated power supply. But if the application is critical, which needs pure, precise power or precise DC voltage, then you have to set one feedback, which will continuously monitor your output voltage, which will act as your eyes on output voltage, and which will give the feedback to the controller or your switching regulator or your normal regulator to change its command. So if your output voltage goes below, so certain parameters needs to be changed. It will tell, no, my output voltage is less. Please increase something so that my output voltage goes high. So this will give some commands, and again your output voltage will be increased. Now let's say my main input is going low. So definitely my output voltage also will go low. So again, it needs this feedback will monitor this, that okay, my output voltage is less. I need to increase my output voltage. So which will give the command to the switching regulator, and it will increase your output. We'll go to this, what is power transformer, rectifier, your smoothing, and your switching regulator. We'll go one by one on that in the coming slides, so you will get more idea. So regulated power supply, there will be three types. One is linear, second one is switch mode, and third one is directly from battery. So linear is the least complicated system, but switched and battery power will have their own advantage. So linear is very simplest, easy to design, mostly available ready-made solution can be used as a linear regulator. But switch mode, yes, we have to design, as it may require some dedicated specifications or some dedicated output requirement. So in that case, you have to design your switch mode power supply, and it will have its own advantages compared to linear regulator. So linear power supply is nothing but it will have one series bus element which will act as the regulator. So if your input voltage is 10 volt and you need 5 volt, so ultimately you have to drop 5 volt in between your input and output. So linear power supply will use variable resistor in between, and whatever output voltage will require, and the difference between output voltage and input voltage will be dropped across that series bus element, which will be seen in the coming slide. We'll go in further. So as I told, it will be very much power dissipative thing. So it will not give your efficiency more than 50%. Even sometimes it will give 30% or less. But in switch mode power supply, your series pass element will not be there. It will not be more dissipative, as it will use some power, some PWM techniques, pulse width modulator, so which will ultimately save your dissipative energy compared to linear power supply. So it will have uh, uh, one dedicated PWM conversion, so which will be used to increase or reduce the amount of input voltage available to the output voltage. So one of the advantages of switch mode power supply is that there is a smaller loss across the switch. So this is the switch. So switcher will be the in-between components of rectifier and input rectifier and output rectifier, because your mains will be your AC voltage, which again needs to be converted into DC. So after that DC, which you will have the switcher, and then after that you will have rectifier, and again after rectifier you will have filter, and output of that filter will be act as your DC voltage output. In battery-based power is a third type of power supply and is essentially the energy storage unit. So you don't need any kind of circuitry to monitor. Once your battery is drained, you will lose your power. So yeah, so it has its own advantage. You don't have any noise or anything with the nearby electronics, since it is DC, pure DC. So using battery exceed driver or control can be damage your device. So we have to be very careful which kind of batteries we are using. So this will give your quick comparison. So in unregulated, it's very simple circuitry, durable, since it does not consist any complex control circuitry. While in regulated, voltage is consistent, which will give constant voltage. As I told, it requires in high quality power supply, but again it needs noise filtering, adjustable output voltage or current, precise tuning. So with these things we can do in regulated, but in unregulated we cannot adjust the output voltage unless you are changing the complete circuitry. For unregulated, disadvantages is that you will not get constant voltage. It will depend upon your input voltage and what load currents it will draw. And it is designed for fixed output voltage and fixed load current. So you already know that your voltage will not, your output will not demand more current than this. So in that case, you will save some cost in unregulated power supply. In regulated, it requires some control circuitry, so it will become complex and it will become more expensive. In downside, we have some comparison between linear, switched, and battery. So you can see it is safe and reliable linear, but switched will have smaller size, and it will be high efficient compared to linear. So switch as because it will not dissipate the energy to regulate the output voltage, and its battery, it will be used in portable applications. So wherever it does not require any conversion, or you need some portable, or you need some space saving configuration, you can use battery operated systems. This is the high level diagram of typical regulated power supply. As we have discussed, it will need, if your input voltage is AC, you will have one transformer which will be act as a step down voltage transformer. Again, it will given to rectifier, which will convert your AC voltage into pulsating DC. And again, your filter will convert your pulsating DC into pure DC, and which will be given to the regulator. That regulator will sense the output voltage, and based upon your load current, based upon your input voltage, will regulate the output voltage fixed irrespective of any changes in load current and voltage, input voltage variations. So yeah, I already mentioned the step down transformer will step down the voltage from the AC mains to the required voltage level. The turns ratio of transformer is so adjusted such that to obtain required voltage value, the output voltage is given to the input of the rectifier. So this is your rectifier. Yeah, all this four diode will act in each half cycle of the AC, and which will convert the pulsating DC. And that pulsating DC will be given to the filter capacitor, which will convert that pulsating DC into DC voltage. So you can see that in that resultant waveform. So without capacitor, and with capacitor, how it looks. So without capacitor, it will be pulsating DC, and with capacitor, it will be pure DC with a small amount of ripple. This is the one example of linear voltage regulation. In that, you can see LM317, very famous voltage regulator IC, which is used for small current application in order to drive some microcontrollers, or in order to drive some small circuits. We might be using LM317, as it will give your adjustable output voltage from 5 volt to 12 volt. So that will be used in many applications. You have to give some input voltage, and which will you have to assume there is one variable register between input and output, and based on this divider registers R1 and R2, you can set your output voltage from the above equation. V out is equals to Vref into 1 plus R2 by R1. So by deciding the R2 by R1 and Vref, you already know. So from that, you can decide R2 and R1 ratio by selecting one R1, and by calculating R2, you can get the desired output voltage. So it's time for some real applications, and in this I wanted to cover one of the simulation software which will be used in many industries, and which are currently in most of the application in order to design your DC converter, or in order to analyze some circuits. You may need one mathematical tool to analyze your circuit. So for that, I will change my screen so that you can all see the simulation software. Can you see my screen?
Wait, sir. That is on the screen. Yes.
Okay. So this is the free software which can get it from Spectrum Software. So you have to just go to the spectrumsoft.com and you will get this free software. Initially, it was some $4,500 cost, but due to some reason, they have closed the software and they have made it free for all the electronic hobbyists or electronic engineers. They have dedicated this software. So all of you can use it for your circuit simulation purpose. So here you can see we have one buck converter given to this, drawn to this simulation software. So we can, I will go through one small example and you can also try it your own. So in that, we'll go to the new circuit. We'll select the schematic file. We'll put one DC source, and in that DC source, you can write DC value, let's say 10 volt. Press OK. Then you can put register from this menu. You can select some 10K value. Here also 10K. And as you know, we need one reference point. So we'll select this ground point and we'll put it here. Now the rest, now we'll simulate just one small divider circuit. So as we have limited time, and using this connector, we'll connect to all the components. So you have to hold your mouse keys and you have to just connect the circuit. So as you can see now, my circuit is finished. So let's just see how much voltage is coming at this divider node. So for that, we'll go to analysis. We'll go to just DC operating point, as I don't want to see the waveform because it's a complete DC circuit. So I'll go to DC analysis and I will just press OK, run, and it will be visible. Your voltage node and node at the voltage should be visible. So now you can see that as it is having same voltage, you will have the 5 volt from 10 volt. Now if I change this voltage to, if I change this resistor to 20K, correspondingly it will change the value. For that, we have this transient analysis, which will give you the waveforms also. So you can see that my V2 will be this node, and my V1 is this node. So you can see the both node voltages, as I have given 10 volt as a supply, and here you will get some 6.7 volts at this node. So you can see that the 6.7 volt here. So this is the simulation circuit. This is a simulation software which is very good. I will recommend to use the software and get as many things from the software. So it has lots of circuits, so lots of demo circuit, sample circuit. You can just look it and you will have the idea. Before finishing my webinar, I just wanted to go through some of real application or real schematics of some 12 volt fast charger. So you can see actually how it looks in schematic. So you can see this is from TI's PMP 21618 schematic, which will which has AC source as an input, and which will give me 12 volt output, which is out with some 3 amps of current capability. So this is the pre-regulation stage, which will convert your AC input to the 6.5 voltage with the 2.5 amps. So this is nothing but one of the DC to DC conversion. But from here it will be converted from AC to DC till this point, till this L1 point, and after that it will give the isolation through this primary through this transformer. You can see it's in the middle, and after that that output voltage will be act as input voltage for this buck boost, for this buck converter, which is nothing but your switching regulator. So which will be act as an input, and it will give the output of 12 volts. In real world it might be look like this. So you might have seen this kind of ports in so many labs, or in your probably in your charger, if you might have opened your battery charger, or if you have opened your mobile charger, or if you have opened your laptop charger, it might be look like this. Some input capacitor, this some chokes, some big bulk capacitors. Then this will act as your transformer. Then after transformer, some of the circuit might be the back side of it. So you can see that this is the controller. So you can see very small size, and which will drive the big MOSFETs to control the power. So I hope you have understood the concept of DC power supply, and where it is helpful or where it is used. So if you have any questions, please feel free to ask. I will rest my session here. Thank you so much.
Thank you so much, sir, for delivering such an informative
Hello.
session
Yeah.
on the DC power supply and
Yeah.
its application. It was
Thank you so much.
really a very fruitful session for all participants. And we must say that the participants can easily cope up with the recent trends and technologies which are used in market with related to DC power supply. And you have also very well explained about the practical simulation of the system for that. And really, sir, it was a very beneficial session. Sir,
Thank you. Thank you.
uh,
Yes. Yes. Please go ahead.
we have one question from the Nirav Mehta. He is asking that what is the range of efficiency of linear and switch mode power supply?
Okay, that's a very good question, Nirav. Usually, linear regulator will have efficiency based upon what is your input voltage. Okay, so if your voltage difference between output voltage and input voltage is very less, then your linear regulator will give good efficiency. Typically, linear regulators are used in applications where your output current is 1 amps to 2 amps, not more than that. And if you are going above that, your typical efficiency of linear regulator will be range from 30% to 60%, not more than that. But in case of switch mode power supply, there will not be any heat dissipating components such as linear resistors. So your output voltage will be converted from the switching of the switches, and it will use the PWM method of your conversion. So it will have efficiency range from 80% to 95% based upon the topology of switching power supplies.
Okay, thank you, sir. So I would like to request Nirav sir to please purpose a vote of thanks.
Thank you very much, Sachin sir, as well as Saunak sir. So
Thank you.
Uh, I think all the participants have take the benefit of your experience and your webinar. And today you have covered many of the topics such as the DC power supply as well as uh, UPS and regulated power supply as well as DC filtration and rectification as well as the practical aspects and practical simulations which are used the spectrum software. So power electronics students as well as our students also understood the use of the spectrum software, which is freeware for all the students, so which will also helpful to all of them. And again, thank you very much, Sonak sir. It was really very informative and interactive session. And on behalf of all the RNGPIT family, all the participants, and our electrical department, I am very much thankful to you, sir, and for giving your precious time and valuable time. So again, thank you very much, Sonak sir and Sachin sir, for cooperating for hold the webinar, and to the RNGPIT Institute. Thank you very much, all of you, and all the participants.
Thank, thank you so much for giving me the time and opportunity to explain DC power supply. Thank you so much.
Thank you, sir.
Once that I have floated a feedback certificate link in comment box. You can give your feedback and attend the quiz. So definitely we'll get the certificate for this online webinar. And your feedback is really valuable for us for continuous improvement. Thank you all.
Thank you, sir.